here is what we are going to do. So we built the Huffman protocol such that we are now storing the actual Huffman array or the data into an array. So now I have the encoding done. So now I need to build the second part, which is the actual is the map, so that I can look up a value that is found within the data that I've encoded, and then to be able to just look it up right away, right? Because I don't want to have to walk the tree for every single byte, right? Just like fully searching the tree, because there's no rhyme or reason to the data inside of a Huffman tree. So I don't want to do that. Instead, I need to be able to have a map that can take all this information and just say, oh, your binary is going to be it looks like, however it looks, 0, 1, 0, 0, right? And then the length of the bits that I need to encode, right? Because that's very important. You need to know the length of bits that you're going to encode. And then I'm just going to have this for every single value. So it's not going to be too hard. I have a pretty good idea of how I want to accomplish this. Thank you, Death. I appreciate that, tier 1, baby. So that's kind of the general plan that we're going to do right now, and I'm hoping I can just get that done pretty much first try. In fact, I'm so confident. This is what we're going to say. We're going to go down here. I'm going to go to this one, manage prediction. I'm going to say this one, start prediction, first try with 3 runs, okay? I get 3 runs, and I will have it. So so what that means is I get to run it once, whatever happens, I get to run it again. Whatever happens, I get to run it again, and at that 3rd run, it has to be successful. There we go. So 3rd try. No, that's first try. In programming world, that's first try. In fact, in programming world, that's like negative first try. That's a Huffman table stake. Yeah. Or Huffman table, as far as I know. Yeah. I'm building a Huffman table. Indexing at -2. Yeah, I mean, come on. Getting it right, getting a Huffman table correct first try is pretty much it's pretty much first try if you can get it correct in 10 tries. Hey Prime, let's say hey Prime, and recommend resources for Lua. Oh dude, it's so easy. Just program for a little bit. You'll do just fine. All right, hey, thank you very much, Cosign. Appreciate that Twitch Prime. And hey, Alex, thank you for that Twitch Prime. Hell yeah. 50? Dude, 50 tries is definitely not first try. Wow, a lot of people don't think I can do it. Okay. The table WebM vulnerability, I don't know. I never looked at the web, or WebP, you mean? The WebP? I never looked at the WebP stuff. Thank you, Sakon. These nuts. The most base split keyboard, back at it again. The most base split keyboard right here. Have you trained for this? No, I've never tried this before. I've never implemented Huffman before, and I've never implemented a Huffman table before. So this is kind of like a TLDR, a specially crafted Huffman table overflows the heap. Nice. Well, the good news is that I don't have that issue. But that is very funny. You need to do Huffman on the Glove 80. Hell no. Hey, thank you very much, Plurks. Have you ever implemented a wooden table? Yeah. JC, appreciate that Twitch Prime. My go-to app is making some kind of text search app that either uses a try or an FSA. PrimeGen seems to make Huffman encoding, decoding. Low level seems to make a hex viewer. No, this is my first try doing Huffman, okay? But I do like to do something with arrays. Typically, whenever I am learning a new language, I like to do a really hard problem with arrays. Because I feel like if you can work with if you can raw dog some memory, you really know what's going on. All right, let me see. How did the prediction look? What are we looking here? Okay, so we got less than half. Okay, so we got more antis. Okay, we got more doubters. I didn't realize that we got some doubters here, okay? But we have a plurality. Look at that. Look how many more people believe in me. We have a lot of people that believe in me and just a few people that just absolutely do not think. Okay, look at this. I met you in real life, Defiasol, multiple times. And this is how we're going to do this? Urias BT. This is where the relationship's going? Press, oh my goodness. That is why. Okay, people. I do not like that. I don't like this. All right, you know what? We're gonna do the Miss Monique. Okay, don't press X. Nobody stop pressing X. Nobody's pressing X in the chat. We're gonna do the Miss Monique birthday special podcast again because I just love it. I just absolutely stop. No more. Prime I'm from Brazil. I loved your Brazil mention show. Do you believe that IA can stole dev jobs? No, not at all. All right, let's get going. So this is my general idea. Watch this. This is what I'm going to do. I think I have this really cool idea in my head, okay? So right now I have a Huffman value to bits. I didn't really know what to call this thing, so I'm just going to get rid of this, I think, for now, okay? Okay, now it's Huffman value to bits is probably fine. I'm going to create a Huffman table, or let's see, Huffman encoding table. I'm going to call it a Huffman encoding table. Why? Because I don't know what else. I don't know what the hell to call it. Okay, I don't know what the hell. Stop it! Stop! No more pain. Funk you, funk off. Okay, buddy. What I'm going to have is I'm going to have this one. I'm going to have bits, and it's going to be a byte array. I know that's. I mean, when you really think about it, it's kind of confusing, right? And then I'm going to have length, which is going to be an int. Okay, yeah. And what I'm going to have is I'm going to have this func h Huffman encoding table, and I'm going to have left, and I'm going to go like this: h dot. Let's go like this. Actually, before I do that, new Huffman table. Okay, hold on. New Huffman table, and we're gonna go Huffman table. Right? We're gonna have this. So what I'm gonna do here is it's very, very simple. I'm just gonna return out a new Huffman table, Huffman encoding table. I think I got this. I honestly think I do got this first try. I'm going to make a new one, and here's the deal. I'm actually going to set the length to be 24. There's no way we're going to get that big, but I'm just going to make it 24. Okay, and length 0. All right, we just start at 0, and so all I'm going to do is go like this: bits h length equals 0, because left is 0, right is 1. Yeah, and h bits. H len plus plus. That's it. Then I'm going to have a right. Oh, man, this feels so good. I actually feel so good about this. And that's that. And then I'm going to have func h. Here, actually, I can just go like this. Pop, right? We'll do a little quick pop here for you guys, because I know how horny you guys are for the screen key. Okay, I know how horny you guys are for the screen key. Okay, we're going to have a pop, which is simply going to go like this. Minus, minus. That's it. So notice we're not just doing a bunch of memory allocations and trying to like slice and pop and do stupid stuff. We're just going to have junk inside the bit array, and that's okay. That is okay. All right. And so now when I do this, when I encode the tree, I'm also going to encode the data map. Yeah. So I'm going to have this I'm going to have the table, which is going to be a Huffman encoding table. Yeah. Yeah. And then I'm going to have, not a bitmap. We're not going to have, we're going to have a bitmap eventually. We're going to have a bitmap eventually, right? We're going to have one eventually. Then we're going to have a bitmap, which is going to be a map of int, and then it's going to have an encoding, what is it, that Huffman value to bits, right? There we go. That's it. That's all we're going to have. I don't think I need that technically. I don't think I need that. I should do that, though. I should do that. Map those bits. We're going to map those bits. Okay, so we're deep in the Huffman and the quad trees. Here we go. So we have everything I think we need, right? And so then I go like this. Watch this. Func. I have one more of these to do. Encode value int. Look at how good this looks. Tell me this does not look good. Tell me this does not look good. We have a bitmap. We hit them with the value, and then we do this one. A Huffman value bits these nuts, right? And oh, man. Oh, man. And oh, man. And okay, just so much man right now. Okay, you wouldn't even understand how much man's going on here. Okay, we're going to have a value. And then our bit count. I realize that this value to bits is not right. We have the value. The encoding value. Yeah. So that's not the value. My bad. That's not what we want right here. The encoding value, we need to change this. We're going to not change this to be an int. We're going to actually change it to be a byte array. Yeah. You ready for this one? h.bits. How do I copy? What's the slice copy? How do I do this? How the hell do I copy? Did you read a book for this? No. I saw how you build a Huffman encoding. And once I knew how you built the Huffman encoding, building a Huffman encoding table makes perfect sense, right? It just seems like good. He was born like this. Yeah, I have been able to build a Huffman encoding table since I came out of the womb. Deleted block term, Nightshade dude. Damn. Copy? No, copy. Does copy work that way? I think so. I think you're right. Encoding value equals make byte. And well, here's the best part is I go like this. h.length, right? And then I go copy, and I'm just simply going to go like this. Encoding value. Oh, man, I'm so happy about this. Bits. Look at that. Look at that. Would you look at that? Encoding value. And then bit count is just simply h.bits.length. I mean, technically, we can just use the length of this thing, but to prevent that kind of, I guess I could just use that, huh? Because I'm creating a specific thing in there for this exact thing, right? I guess I could. We could do that. I guess I could do that. I don't even need this, huh? Because I kind of actually have that in there. Yeah, I can just go like that, huh? Yeah, that probably will work out. We'll see how I feel about that. I don't know if I don't know if I'm going to regret this or love this. I don't know if I regret it or love it, but we're going to find out. Is it true that you solve 80% of your problems in the back of your head? Yes, sort of. The thing is that like this encoding table, what happened this morning is that I got in here and I said, man, I got a program today. We're going to crush it. What am I going to do today? I looked at this code and said, oh, yeah, I got to create a table. And I just had all these ideas floating around. And so I was just like, man, I don't even know. And so I just kind of walked away. And then as I was walking away, I was like, wait a second. Pushing and popping sucks when it comes to an array in Golang. I could just wrap it, make my own left-right pop. Hell yeah. And then boom, did it. So I didn't think about this. This I just made up on the spot right here. But the rest was just there. The rest was there. Okay, that's too loud for you guys. Sorry, I'm getting into this. I'm getting way into the music right now. Shower completion, yeah. Popping and locking, dude, baby. You know it. Popping, locking. There we go. A bitmap is that thing. Beautiful, right? Beautiful. All right. So now all I need to do is just create this Huffman table, which is going to be pretty easy. Table equals new Huffman table. There we go. And I have my table in here. There we go. And I just do a table bitmap. Perfect. Bada bing, bada boom. So it's like almost done. So now all I need to do is just do the table. I got to do some table, boys. Boys, we're doing the table. Okay. So check this out. Check it out. Check it out. Okay. When I encode the tree to the left, what do I got to do? I got to go like this. I got to go table.left. Boom. Okay. And you know what I do? Table.pop. We walked it to the left. We walked it back. Okay. Pretty easy. Recursion. You may have heard of it. If you're probably some loser that doesn't even know how to recurse. All right. And then we do it again. Table.right. Yeah. And then a pop, table.pop. Bam. Look at that. Oh, yeah, that's feeling good. If left equals right, then we got to do that thing. I don't need to do that anymore. You know why? You know why I don't need to do... Oh, yeah, I guess I do need to do that. Or do I need to do that? I don't need to do... I don't need to do that because look at this. I now go like this. Is leaf. I built a nice little method right there that makes me feel good about it. So if I have this, I just simply have to go like this. Table.encode. And I just need to hand it the value. What the hell is my value today? It's going to be, what is it? It's not count, it's value. That's right. I actually think I just did it. That's it, boys. Boys, I think we just got done doing it. That's it. That is it. Easy peasy, first try squeezy. Okay, so before I say we're done here, we got to validate that I've done this correctly. And since I only get a negative second and a negative first and a 0th try, I really got to be kind of careful here, okay? So what I'm going to do is I'm going to do the following, okay? I'm going to go like this. Format, printf, table, and I'm just going to plus v that table. I'm pretty sure that should work. Actually, you know what? Let's go like this. Let's be smart about things, huh? I'm going to go like this, table. Now, here's the best part. You know what my table is? My table is this beautiful Huffman table. And I'm going to go up here and I'm going to go like this. Funk. Yeah, funk me daddy. Funk me daddy. Hit him with that string. Hit him with that string. And let's make a nice little, let's make something nice here. Let's go like this. Let's go, who cares about performance? Okay. Who cares about performance right now? Sprint F. And let's add in encoding table. And we're going to have its current length, followed by its current set of values, right? Its current binary values. In fact, I'm just going to go like this. I'm going to do that. Yeah, this is looking good. This is looking good, people. So we got our length. Oh, yeah. Oh, yeah. Oh, my goodness. Oh, yeah. B, range over h dot bits. Yes. Yes. Okay, who cares about performance? I know you could. I know. I hear. I can hear everybody right now telling me all about a string buffer. I've never used string buffer. I don't really care as of right now. Dylan Mulroy, the man, the myth, the legend. RESPECT. Respect. Did you know that that's what promise is? You know how they return res and reject? You know what res stands for? Res stands for respect. Okay? Don't forget that. And that's how I feel about you. I'm stuck in an ad? Well, dude, Dylan Mulroy, you have a Twitch Prime, you loser. Imagine having a Twitch Prime, you loser. Oh, man. Oh, baby. Oh, just Alex. Oh, just Alex. You just Alex. Oh, thank you, N1000. You messed it up, Alex. Alex. You done messed it up, Alex. Oh, yeah. Alex, you just messed it up. You know why? I don't know if you know this, Alex, but chat is, of course, MIT. You got to give it a little bit of vertical space, or else Twitter will not render it correctly. This is just how it goes, Alex. Alex. Boom. Alex. Should have known about it. I just got hit with a 2-minute ad. Never subbed so fast. Let's go. Well, thank you very much. Thank you, Damios, for the tier 1 6 months in advance. Damn, I can't hear anything. I'm sorry. I love you, Dylan. Appreciate that. Let's go. At me, you coward. Sorry, MIT. MIT, baby. It's not my fault. You just got MIT'd. Oh, what's his Vim color theme? Right now, we are on a delicious rose pine moon. Okay, we're mooning. We're moonlighting right now. We're moonlighting. Okay, moonlighting. All right, it's delicious. All right, so let's go like this. So we have the encoded table, and then I'm just going to go like this. I'm just going to go format sprint F, and I'm just going to hit him with the % D's nuts, right? And I'm just going to go like this. I'm just going to go, no, we're not going to do that. We are going to range over h.length, because remember the 5th of December, okay? I don't even think that's what it is. I think it's something else. We're going to do that. That way we see our encoding. Okay, fantastic. And then we're going to go out plus equals new line. And we're going to go for K value in range h dot. What the hell is things called? It's called a bitmap. I don't know why I made everything capital letter. This is a completely private structure. And then I'm just going to go like this. Ooh. No, this one's hard. We're going to go like this. Okay, so I'm going to go out plus equals. Yank that one. Put that down here. I know, string builder, I hear you. I know string builders are great. I just don't care right now. We're going to hit him with one of these, right? Except for we're going to take that thing out. We're going to hit him with the K. We got the K. And then we're going to go like that. And then we're going to go 4. Now, this is where things get a little tricky, okay? Okay? This is where things... Okay, guys, it gets a little tricky right here. He's taking the funk. Oh, we're taking the funk, boys. Boys, we're taking the funk. Let's go like this. Watch this one. I feel good about this one. Okay? I feel good about this one. Oh. I don't even have to do that, do I? I forgot that I can just go like this. Can't I? Can I do that? Can I just join all the numbers and make them into strings? Probably not, huh? We can't join them all and to make them into strings, can we? We can't. So I'll just go like that. Whatever. Let's see. What is this thing called? Let's see. Bit. There we go. Perfect. People, this is so good. Look at that nice little string I just made. So every time we go in here, we're going to have this, and I'm going to go table for value. This is for node.value. So for every value, I'm going to write in this nice, beautiful bam, 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 right? It's going to be this nice, beautiful table so I can see it all the way through, okay? All the way through. And then I'm going to go down here, and I'm going to go like this. Encoding table, right? Or encoding value. Encoding value, %d. Yeah. Yeah, yeah. Yeah. Hell yeah. Hell yeah. Hell yeah. And then we'll just go like this. I'm just going to go V to be lazy. I'm just going to go V to be lazy. Okay, we're just going to go V. We're just V'ing it. We're just V'ing in the D's in. You know what I mean? Value. And then we're just going to go table.bitmap node.value. You know what I mean? There we go. That looks good, huh? All right, so now it's time to write a test. Okay, I'm going to write a test. Huffman table. Are you ready for this? I don't think you're ready for this. All right, there we go. Let's create a nice freck table. Oh, we're frecking, boys. Boys, we're frecking. Who here's ready to freck? Who's here ready to get frecked up? I ain't ready, Captain. You're about to. I'm about to finish a Monster Energy Paradise Ultra. What a mouthful. I'm ready to refactor into a strategy pattern and kick the living hell out of some code. God, it's good to be alive. Let's go. Wow. Okay. Hey, maybe you don't want to do a Monster Energy Paradise Ultra. Okay. I'll freck you. Let's get frecked up, boys. All right, so this is our freck table. Look at our beautiful little freck table right here. We have our encode length. Okay, we have our Huffman. This is kind of the shape that I expect out of it. But today I don't want to look at that. Today we're not looking at that. Okay, we're looking at something a little bit different. Okay, since I expect this shape, I already know the shape I'm about to get. That means I have to just recreate this now. Who just subscribed? Hey, thank you, Happy Beard. I appreciate that. Okay, with that tier 1 baby cakes. Thank you. Monster Sussy Lemon Slap Stam. Thoughts on strategy pattern being used a lot in machine learning frameworks? It's because strategy pattern is the greatest thing in the universe. That's why. Okay, so let's do this. So that means if I look up here, this is what I see. This is head left. So A is just a 0. Yeah, A is a 0. Yeah, hell yeah, hell yeah, hell yeah. Okay, A is a 0. A is a 0. So if it starts off with a 0, boom, we encode it. We just encode that. We encode that SOB, right, which feels pretty good. So that means I should have the following table. I should be able to go like this. Require equal. Let's go like this. Data.bitmap, and then I'm going to have A in here. I just want to do them one at a time. That way it makes sense to me. You know what I mean? T, and I'm going to go like this. Byte 0. That's what I expect. Yeah? That looks good, right? Yeah, I think it does look good. That means I'm going to go like this. That means I go right, which is a 1, goes here. Then left is a 0 again. Okay, so left is a 0. So that means I'm going to have 1, 0 being a B. Such a B. That means I have 1, 1, 0 being a D, if I'm not mistaken. Give me that D, boy. And then I have C right here. F0. I'd love to know how to balance a Huffman map. I know there's a way to balance a Huffman map, but I'd like to know how to do that. A, B, D, C's nuts. Yeah, it's just what happens. There we go. So I have C as all ones there. Perfect. Look at that. I even have it right here. Awesome. 0, 1, 0, 1, 1, 0, 1, 1, 1. Let's go. Because technically I should be able to have this. If I were to have this balanced, A should be 0, 0. Right? You could imagine that'd be good. B could be, what's it called? If these were evenly distributed, you'd want that. If there's a huge difference between them, right? Like that would be great to have something like that, right? But, if A occurs a bunch more, maybe that single byte's really good. I don't know. See, that's the thing is I don't actually know. I don't actually know. Excuse me, sir. I just opened the stream. I heard you say, give me the D. What the heck? Well, I'm in the middle of D getting. Okay. All right. So here we go. Try number 1. Now, remember, if I run a test without -v and I forget to run -v, it doesn't count as a run. Okay, because I haven't changed anything. So I can run it over and over again all I want. That doesn't change anything. Okay. Go test. See, it's always trying to get me. It's always trying to get me. It's always trying to get me, and I don't want to be got, but it's trying to get me with that dash V. All right, so this should give me everything I need, but just because I'm feeling a little extra sensitive right now, you know what I mean? I'm feeling a little sensitive, like I could get this wrong, even though I don't think I did. You know what I'm going to do? I'm going to go like this. Format, print F, a Huffman, left. Right, so I'm just going to have some nice lefts and some nice rights, just so I can see it happening. That way we can just see it happening, right? Because you want that. Format print F, nil node. There we go. Okay, so we should be able to visualize the tree in text. Are you guys ready for this? Extra version. This song sounds like lyrics to a decent song. That's right. Here we go. Okay, build failed. That's fine. That's fine. Huffman, go. Sprintf, arg, node value, wrong type, int. Okay. Wait, what? I think this counts. I think this counts because this was a runtime failure. Damn, that's a tough runtime failure. I'm not going to lie to you. That's a tough one. That's a tough runtime failure. I'm surprised I didn't get hit with a, that's just a tough runtime failure. Tough runtime failure. Okay, so this is run number 2. All right, let's see what we got here. All right, so we're running. We got table 0, encoding table 0. Okay, cool. We got table with a 65. We're encoding table with 1. Okay. I mean, I like what I see. With 0. Yeah, that's right. We're going to hit him with the left. Left, nil map, pop. Right, nil map, pop. Damn, that's not a way to go down. Oh, man. Okay, so this looks right. Based on this, I think I'm right. Damn. Imagine, dude, I've got had by two of the, dude, doubters are salivating. I got had by the 2 worst bugs to get hit by on a single day. Like, I got a non-build error, but a runtime dumb error that just really effed me up. Dude, killed by Go. Today, I got killed by Go. Today, classic learning curve of Go right here. We already went over this yesterday, right? Where was it? Right here. No, right. Where are you? Yeah, right there. Look at this. Right there. That's like learning step number 2. Maps are nil by default. Classic owned right there. Just an absolute classic owned. So I guess this is my last run, people. Oh, that's looking good. We encode value 65 at 0, yeah. We encode value 66 at 10. Okay, I mean, that's right. Okay, this is looking good. This is looking really good. In coding table 3, yeah. I mean, that looks good. That's looking good. We encode that one. That's looking good. Wait, what did it fail on? Wait a second. Let's go. It passed. Let's go. Huffman table passed. Suck it. That's a W. Do I have a failure? Oh, I have a failure. I have a failure in the other one. Let's go. Suck on that. I did it. Huffman table. Let's go. Huffman table. Let's go. Got it. You suck. How does that feel? How does that feel right now? How does it feel? Task failed successfully. Dude, how great is that the Huffman table passed? We created it with ferocity. It's the other one that apparently I have a broken value in. Let's see what happened to this one. So this is on the other Huffman test. Not equal. Expected 0, 0, 0, 0. Yeah. I mean, this all looks correct. Did I do something goofy? Did I goof it up? Here, hold on. I want to be able to, like, see what I did in this one. Here, let's just grab. Oh, yeah. I changed the return value. Okay, yeah. That one's an easy fix. This one, because look, I expected it to be a byte array that comes out of here. It's actually a Huffman. So all I have to do is go like this. Bitmap goes into here. Right? I'm so happy I created this as a separate test, because if I wouldn't have created this as a separate test, this would have just simply failed. So if I do that, is that what it is? Oh no, not bitmap. What is it? What the hell is the thing? Encoding. There we go. The other one passed. Let's go. How does it feel, by the way? How does it feel? How does it feel, losers? How does it feel, doubters? Hey, thank you, Smushed You and Flow Res. How does it feel? How does it feel? How does it feel? JavaScript is bad. What did you have to say? I use Vim, by the way. I love you. I absolutely love you. I absolutely am in love with you. Let me just reward the people. Yeah. I successfully created a table. First try.